Hi guys, in this video we are going to discuss the problem from weekly contest 327. So this was the second problem, I guess, and the problem's name is maximal score after applying key operation. The problem states that you are given a zero indexed integer array nums and an integer k. You have a starting score of 0. In one operation we can choose any of the indices I, which is a valid index obviously, increase our score by nums I and replace nums I by ceil of nums I divided by 3. So when we say ceil, what we basically mean is that if there are some uh, numbers after the decimal point, if it's a floating point number, then we'll like choose the next greater number. So let's say if it's 3.14, that's the value of pi, then we'll have to choose 4. Also, we'll have to return the maximum possible score you can attain after applying exactly k operations. So then they have defined what ceil is. So it's the least integer greater than or equal to the val. Yeah. So this is example over here that they have taken. So over here k is equal to 5. So in each step we can actually select these ones. So how would we do it? Let's talk about this. So this is fairly a simple question, but if you don't have any idea about maxip and stuff, so this might become a bit difficult for you. So let's talk about the naive approach first. So what we want to do is that initially we'll select any element x, right? We'll add x to our score, and then we'll push back x, but we won't push back x completely, but we'll push back x divided by 3 sealed. So this is what we're trying to achieve. Now there's an easy way to do it. So let's say we have an array, there are some elements. So in each iteration, for k iterations, because k number of operations can be performed, in each operation I'll be going through the entire array. I'll select the maximum element, right? I'll add the maximum element to my score, this element, and I replace the maximum element by n divided by 3 sealed. So this is an easy way of doing it. Now what's the time complexity of this? So the time complexity of finding the max element itself would be order of n. We are running it for k iterations, so the time complexity turns out to be order of k n. Now let's see, would that satisfy? Let's check. So over here n and k both are of the order of 10 to power 5. So n into k becomes 10 to power 10. It's definitely a TLE, so we can't go with this particular approach. What's next? What's the other approach we can use? So we can say, so since in every iteration we just care about the maximum element and no other element, right? So we are just trying to fetch the maximum element itself and then replace the maximum element by some other value. We can say that an obvious choice over here is a max heap. So for those who don't know what a max heap is, so a max heap is a data structure which actually contains the maximum value at the uppermost node. So this would contain the maximum value. Now the benefit of using a max heap is that you can fetch the maximum value in order of 1 time. That's doable. You can delete the maximum value in order of log n time. So that's also cool. Also we can add any element to this max heap structure in order of log n time. Perfect. So that's all we need. So in one iteration, for the k iterations I meant, what I want to do is that I want to fetch the element, greatest element. Then I want to delete the greatest element, and then I want to add greatest divided by 3 sealed. So all of these 3 operations can be done in order of log n time at max. Hence my final complexity would be order of k log n. Perfect. That solves, right? Order of k log n would definitely pass and give us AC. So how do we implement a priority queue in or a max heap in C++? So in C++ we have a data structure called as priority queue. So that can be used. In Python we have something called as heap queue. So people who are using Python can use heap queue itself, and that should do the entire trick. So we don't need to implement the priority queue on our own. You can do that if you want, but not required. So you can use the inbuilt functionalities. So let's try to code it up now. So what we are saying is that we need a priority queue first of all. So priority queue UE, let's give it a value int. Let's call it PQ, and I'll pass all the numbers or all the nums into this priority queue. Then I'll set my final answer long score. Initial value is 0. I'll also start iterating over the queue k times. Now what I'll do is, So my val is, let's say my val is pq dot top, so that would give me the biggest value possible. I'll remove now. So pq dot pop is used to remove the value. Now I'll have to add this value back. So initially, let's firstly add it to my score. So I'm adding the value to the score. This is multiplied by val. Yeah. So when I'll be adding the value, what I want to add is a ceil operation. So I can add it like this: ceil val divided by 3. But a better way of doing it is, so we can obviously use that, but a better way of doing it is val plus 2 divided by 3. So why val plus 2 divided by 3? I have explained this particular concept in a lot of videos, but what basically it means is that when we want to ceil, when we want to find the ceil of any a divided by b, then we can basically say its ceil operation is integer division of a plus b minus 1 divided by b. Now why it is so, you can let me know. I like make a short video on this as well, but yeah, that's how it is. Then we can return the score. Cool. Let's see if this works. Yep, it's giving the right answer for the first test case. Yeah, and it gets accepted. So this was kind of the exact code I wrote for the contest itself. So if you write such codes, then definitely your like time is gonna reduce. You are gonna able to write it quickly. So yeah, that's it for the video. If you have any doubts, please let me know in the comment section below. Thanks for watching. Bye bye.